Hello, everyone, and thank you for joining today's session on deploying ML.NFT models to the Azure Container Apps. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and our presenter. We encourage engagement in the chat. This session will be recorded and available on the Microsoft Reactor YouTube channel in 24 to 48 hours. Useful links will be shared in the chat, which brings us to today's session. This session will run approximately 1 hour with questions for throughout. Today's speaker is Lewis, who is a developer for Microsoft. Hi, Lewis. I'll let you take over from here.
Awesome. Thank you so much. All right. Well, welcome everyone. Good morning, good afternoon, good evening. Thanks so much for joining us today and joining this session where we're going to be talking about deploying ML.NET models to Azure Container Apps. My name is Luis Quntanilla, and I am a program manager here at Microsoft. I specifically oversee the development and building of the ML.NET product, which we're going to hear a little bit more about what ML.NET is. But I also have experience working with a variety of products that include ML.NET, Azure Machine Learning, as well as .NET for Apache Spark. You can find me at Twitter at that handle there. You can also email me at that address there. And of course, my site, lqdev.me, where you also find some of these resources that we're going to be talking about today. All right. But before we get started, I'm going to go ahead and talk to you about or walk you through what we're going to be talking about today. First of all, we're going to start off with the machine learning workflow, and just basically what are the steps to build that you would need to take to build a machine learning model. After that, we're going to talk a little bit about what ML.NET is. Then I'm going to go into a demo of how you can train models with ML.NET. I'll speak a little bit about what Azure Container Apps are, as well as how you can then deploy those ML.NET models using Azure Container Apps. So that's roughly what we're going to be talking about today. And I mentioned resources. Any resources that I talk about, whether that's source code, documentation, slides, anything can be found over at this link here. I also did this talk or something very similar to it a couple of weeks ago in Spanish. So if we have any Spanish-speaking folks in the audience who would prefer to listen to that talk that way, in that language, right? There's also that option for you as well. And there's very similar things, right? Have code and slides and everything. There's even a recording for it. So make sure to check that out again for Spanish-speaking audience if you'd like to learn more. Okay, so let's get started. What is the machine learning workflow? Well, roughly, it consists of a series of steps. Now, before you even go into any of these steps, you have to have a bit of a knowledge or you have to ask the question of what exactly is the problem that I'm trying to solve, right? So am I trying to forecast my sales? Am I trying to predict the price of something? Am I trying to classify sentiment? What exactly is it that I'm trying to do? All right. And once you kind of have a rough idea of what problem it is that you're trying to solve, then you sort of kick off this machine learning workflow or this machine learning process, which starts off with getting the data. So in the step of getting the data, you have to ask yourself questions of, do I have the data on hand? A lot of enterprises have tons and tons of data, but it's really hard for them to sort of sift through and try to understand, well, what data do I have and how can this data help me solve my problem, right? Perhaps sometimes you may not have the data. So, thinking about how am I going to go and collect that data? How am I going to store that data? It's going to be in a database, in a SQL database, no SQL database, in a data lake. Where is this data going to live? And also, sometimes you may even have to supplement that data with publicly available data. For example, there's a lot of government portals. So, for example, City of New York in the United States, City of Chicago, a lot of the major cities around the United States, as well as internationally, they publish data from the government, right? So being able to use that data that's publicly available to supplement it with your own data to try and solve your problem, right? That's what getting the data consists of. Now, data itself is not always clean and it's not always ready to go. Now, sometimes perhaps you've done tutorials and, maybe even in this demo, right, the data is going to look fairly clean and just ready to go. And you can just start building and training your machine learning models. But oftentimes that's not really the case. You usually have to prepare the data. Now, typically preparing the data consists of a variety of things. And actually, this is going to be where you're going to be spending a lot of your time. And you're going to use hopefully have the assistance of some subject matter experts in whatever it is that domain that you're trying to sort of prepare the data in, so that they can help guide you through this process. But preparing the data would consist of things like, maybe you have missing data, right? So you have missing data points. So thinking about, okay, well, what's the best way for me to, should I just toss that? Is that data point significant enough? Or can I keep that data point in there? But then I would have to, think about, how do I impute it? Like, how do I fill in that missing value? Right? What's the best way to go about that? You might have duplicate information, right? So again, that's very common that you have, multiple entries, or maybe you might have misspelling and things like that. So trying to reconcile your data and get it to a point where it's clean enough that it represents the state of the world that you're trying to model is a really important process. It's also important in the sense that it helps you understand what it is that you're looking at, because during the step, you're trying to build you're trying to build a mental model of what exactly, and you're trying to build a story out of, okay, what is my data trying to tell me? And can I use this data to sort of help me solve that initial problem and answer that initial question that I posed at the beginning of this workflow? Now, let's assume that you've gone through this process of preparing your data. You got basically the inputs that you're going to want to provide your machine learning model with. And that's where the training phase comes in. So during the training phase, that's where you select an algorithm that you apply to the data that you've prepared, right? And which algorithm you choose is going to depend on what type of problem you're trying to solve. So there's many different types of sort of machine learning algorithms, depending on whether you're doing machine learning tasks like regression, you're doing classification, recommendation, whatever it is that you're trying to do. There are certain algorithms that are specific to that particular use case. Excuse me. So what's happening at that point is you're going to want to select the best algorithm for your particular model, and then use that to sort of train your machine learning model. Once you have a model, you're going to want to evaluate it, and you're going to want to determine how well does my model perform for this particular scenario? How well is it getting the answers right? And the evaluation actually takes different forms. So there's certainly the form in which you're using metrics to try to determine, is my model performing the way that I would expect it to. But there's other things that you should take into account when you're evaluating your model. One thing is, how easy is it for me to build my model? So for example, let's say that whatever metric is you're choosing, let's say that 100% is the maximum for that metric. And let's say that you're getting 100%, and your model's getting 100% of accuracy, or whatever it is, that metric that you're choosing, right? So it's the best model ever, and it's perfect, and so on and so forth. But if it takes you, I don't know, 6 months to develop that model, to prepare the data, and get everything in order, for you to go ahead and train that model. But then let's say that maybe there's another model that's, I don't know, 97% or 96%, but it takes you a week to build it, right? Sometimes it might make more sense to sort of trade off, that sort of drop in accuracy, or whatever metric it is that you're optimizing for, because it's easier for you to iterate, and it's easier for you to build that model, right? And part of that evaluation also consists of trying to, understand what your model is telling you. And in a lot of cases, this evaluation, you often ask, like, okay, well, what's the best model? And it really depends on the scenario, right? It really depends on what the stakes are. So for example, let's say that you were, I don't know, categorizing GitHub issues or something like that. Now that's, it's pretty important, and it's something that you definitely want to take seriously. But at the same time, it's not the same as, say, for example, providing a diagnosis for a disease, right? So being used in the medical space to diagnose diseases. The stakes at that point where you're diagnosing and prescribing certain actions, depending on what the model has done, right? The stakes are just a little bit higher there. So you want to make sure that as you determine what that metric is this good enough? You take into account, what the stakes are, and how what the impact of making these decisions based on the model has on individuals, and just overall in society. Which leads me to the other point of evaluation, which is you really want to understand what your model is telling you. So, for example, going back to that scenario where perhaps you are trying to diagnose a disease, right? Perhaps you're trying to prescribe something, and the model tells you, hey, based on what you told me, these are all the different symptoms. Here's what I think that this person has. You can't just take it at face value that that's the right answer. You can't just say, well, the model told me, therefore that's why I went ahead and made those decisions. You definitely want to have a human in the loop, and as part of having that human in the loop, you want to be able to have them understand, why did the model arrive at this decision, so that later on, when you're looking back and saying like, oh, well, based on these factors, we think that the model made the right decision or the model didn't make the right decision. You can certainly go back to that and you can inspect it, and you can sort of have try to interpret what it is that the model is trying to tell you, and what exactly are the factors that contribute to the model making that decision. So it's ultimately important. Now, oftentimes what's going to happen is you don't just create your model and that's it. You got a model and you go ahead and ship it or you deploy it. This is going to be an experimental and an iterative process. So again, you choose an algorithm, you prepare your data, you evaluate it, and then at that point, maybe your model is not good enough. So what do you do there? Well, maybe you need more data. So you go back to get the data and prepare the data. Maybe you choose a different algorithm for this particular problem. Maybe it works better for your data set based on what your data looks like. And you go, over and over through this process until you find what that model is. Okay. And then, okay, so let's assume that you've gone through multiple iterations, you found the model that works for you. So the next step is you go ahead and you deploy this, right? And typically the way that you deploy it is through some sort of web service. What you get as a model is typically some sort of serialized, file that represents all of the different transformations, all of the different the algorithms, the parameters that were used, and it contains all of the state that your model sort of learned throughout the training process, so that you can then apply it for inferencing and for making predictions, right? So these steps are typically sort of split into the model training aspect of it, which we're going to see a little bit of. And you also see the model consumption aspect of it, which is when you deploy it and you actually use the model to make predictions. So that's in general what the machine learning workflow looks like. Just 1 second here. There we go. Okay. So now let's talk a little bit what ML.NET is. But before we talk about what ML.NET is, why would you choose .NET? So maybe you've heard that if you're going to build machine learning models, Python has a wide and diverse set of libraries that can help you do that, and that is true. So in that case, why consider .NET? Well, one of the reasons is in part because of that deployment phase. And on top of .NET being a very performant sort of runtime, it also has an ecosystem where you can build tons of different applications. So that means that you can build applications for the desktop, you can build applications for the web, you can build cloud native applications, which we're going to see a little bit of today. You can build with Xamarin, build mobile applications. Whether it's gaming, so you can use some things like Unity or Godot to build games. And one of the aspects of gaming that's actually super interesting, as we go forward in the next few years, is that you can use a lot of the same software that you would use for gaming, and a lot of those skills as well for things like mixed and augmented reality, right, and virtual reality as well. So gaming is a super interesting space. IoT, again, same thing. You can build applications for IoT devices, whether it's a Raspberry Pi or microcontrollers. And then last but not least, we have AI, which that's sort of where the .NET for Apache Spark and ML.NET, which we're going to be talking about later, sort of falls under. So it's really nice that you can still continue to use the same set of skills and the set of tools. So for example, C#, F#, programming languages, you're going to be able to build effectively any of these application types. And likewise, if you're used to working with Visual Studio Code, you can use those same tools to build any type of application that you see on here. So .NET is really powerful in that sense, where not only can you build these applications, but in the case of machine learning, you can also deploy your models once you've trained them to any of these application targets. So yeah. So with that, what is ML.NET? Well, ML.NET is an open source cross-platform machine learning framework for .NET. So to give you a little bit of history, this was something that was used inside of Microsoft for quite a few years in products like Office and Bing and all sorts of products. And it was known under at the time, it was known as the Learning Code, or TLC. And so a few years ago, Microsoft decided to make this public and expose this to .NET developers, and that's sort of where ML.NET came in and modernized it to sort of more modern .NET Core, now .NET standards, and just made this open source so that .NET developers could also take advantage of all of this rich ecosystem and this rich framework for adding machine learning to their applications. So some things that you can do with ML.NET, you can definitely train custom models, which is what we're going to be doing today. And that means that you use your own data, you choose an algorithm, and it's all built from scratch. However, you're not only limited to using ML.NET models, you can also use Onyx, ONNX, which is this interoperable sort of format that you can sort of convert your models into or store your models in. So again, remember that I said that models are typically just a serialized, some sort of serialized file or a serialized component that contains all of the state about a model that's then used to make predictions. So Onyx is just a way that allows for different frameworks to sort of interact and interop with each other. So let's say that maybe you're working with data scientists and machine learning engineers who have built a model, they've trained a model using something like PyTorch or some other framework in Python. If they were to convert that into Onyx format, you can then take that model that somebody else built and you can just use it you can consume that model and use it to make predictions inside of your .NET applications. Again, you can use TensorFlow, which is a very popular deep learning framework, and you can use that to consume pre-trained models that were, again, trained in TensorFlow. So that's an option as well, right? So not only do you have to stay within the ML.NET ecosystem, but you can also use some of the popular libraries out there or consume models that were created with some popular libraries in Python, right? So it gives you a lot of flexibility there. Again, ML.NET was built for .NET developers. You can stay in the .NET ecosystem. So again, use those C# and F# skills and the tooling that you're known and where you have experience with. And you can use that experience to then integrate machine learning into your .NET applications. And again, there's a wide variety of applications that you can deploy these models to. Later is that data science and machine learning is not required, or the experience is not required. Well, it helps. It certainly helps, and you can definitely do a lot more advanced things with it if you already have that knowledge. I'm going to be using some of the tooling that ML.NET provides to show you that it's relatively easy to just get started and prototype and build a machine learning model and see whether this is something that can help you solve your problem, right? And then once you sort of get an understanding of what the process is, then you can go ahead and sort of continue learning from there and try to pick up these skills. But again, it's not a requirement off the bat. And last but not least, it's easy to go from experimentation to production. So because it's all using the same framework, you train with .NET and you consume your model inside of the .NET application. It's all on the same stack. One of the challenges that you often see in industry is sort of that handoff process between data scientists and the folks who are working on putting these models into production. Oftentimes you have to rebuild because maybe your application is using some other framework or some other stack, maybe .NET, Java, whatever it is, but the models are trained with Python. So it's a really difficult challenge to solve. But if you're doing everything in the same stack, using the same tooling, the same set of programming languages, and the same paradigms, it makes that process of going from that experimentation, so that model building aspect of it, the model training aspect, going into that model consumption, sort of series of steps of deployment and inferencing. So there's a lot of advantages there. What exactly can you do with ML.NET? I'm just going to sort of get all of these on the screen. There's different types of scenarios that you can sort of train models for inside of ML.NET. So the ones on the left here are typically known as classical machine learning algorithms, and the ones over here are more deep learning set approaches, which is a subset of machine learning actually. So for example, you can do classification. So classification is, again, kind of what I was saying before. Sentiment is positive or negative, which is the scenario that we're going to be doing later. It could be something like spam or not spam. It could be categorizing GitHub issues, right? So that's classification. Regression is when you're trying to predict the numerical value. So that can be the price of a house, how much the fare of a taxi cab will be, things like that. Forecasting, as I think I gave an example earlier, where let's say that you're trying to sort of forecast or project out into the future. Hey, based on our historical trends, what do we think, the next 3 months, the next quarter of sales is going to look like? Anomaly detection is trying to identify sort of odd patterns, outliers within the data, and sort of raising flags based on those. So an example would be maybe something like credit card fraud, right? There's a transaction that looks odd, so it will raise a flag. Or maybe it's something like power consumption. There's a spike in power consumption, so you want to be able to catch it so that you can sort of take action there. There's ranking. So for ranking, you can think of this sort of how let's say that you go on your favorite search engine and you try to you perform a search. You're given results that more closely match what it is that you're trying to that provide an answer to whatever question you're asking. All right, so that's sort of ranking. Clustering, that's a scenario where you're trying to understand how do different groups relate to each other based on different characteristics. So you might think of an example of this being something like customer segmentation. Let's say you have a database of customers and you're trying to understand how do all of these customers relate to each other, or what are the groups of customers within my database that are alike, right? Recommendation is probably something that you're familiar with. Maybe you've used done some online shopping, or maybe you're using your some favorite for some streaming service to watch movies and TV shows. And recommendation is what it sounds like. It's trying to give you, based on your prior watching experience and other users like you, trying to provide you with a personalized and tailored experience. So that's a classical machine learning approach. And again, all of these you can train with ML.NET. Now you have the deep learning scenarios. So you have image classification and object detection. So image classification is a sort of a subset of classification however, it's specifically tailored towards classifying images. So you might have multiple images, and you might want to categorize that. Oh, these are mountains. Perhaps it's landscapes, right? And you have these are mountains. This is desert. This is a river. Whatever it may be. So image classification can help you with that. And in ML.NET, you can train these models using a process known as transfer learning, where you take a previously trained model and you just use your own data to try to create a model of your own. And what that leverages is TensorFlow.NET, which is a set of TensorFlow bindings for .NET. And you also have object detection. So object detection is also a computer vision problem, except as opposed to classification, where it just tries to select and classify a single item. Object detection will tell you within an image. For example, let's take this here. It will tell you, oh, this is a plane, and this is a plane, and this is a plane. And it will give you bounding box information of where specifically within the image this particular item is located. So that these are the sort of the deep learning approaches that you can do with ML.NET. And again, with these deep learning approaches, you can take models that were trained in TensorFlow. You can take models that were trained with PyTorch. And as long as they were either, they are in TensorFlow format or they are converted to Onyx, you can just bring those models into ML.NET and use them to sort of consume inside of your .NET applications. Here's a little bit more about the ML.NET platform and how it relates. I talked about tooling and different things, but I also talked about C# and F#. So how exactly does that all look like within the ML.NET platform? So at the base here, you have the ML.NET API, and that is at its base, it's a set of NuGet packages. Most of them starting with this Microsoft.ml sort of prefix. And you can just go to NuGet and download it, and you can just start getting into code. Right, and you can have this code first approach. This is the option that's going to give you the most flexibility and the most autonomy in terms of what it is that you're trying to do, because you are the one that's basically building everything: the pipeline, how you load your data, what transformations are you going to apply to your data, basically all that end-to-end process of the machine learning workflow. You're just doing it in a code first approach with using C#, F#, and whichever tool you use to build your applications with. Now, I mentioned that. That process of preparing your data, so applying certain transforms, training your model, choosing the best algorithm for your data, and evaluating it. It's a process of experimentation, and it's an iterative process where you go back and forth until you find the best model. So that can be time consuming, and also for somebody who doesn't necessarily have that sort of deep data science knowledge or experience, and they're just getting started, it could be very daunting in terms of, okay, well, what should I do? Why should I do that? So on and so forth. So at that point, something that you can leverage is AutoML or automated machine learning. And ML.NET has an AutoML API, which again, it's still a code first approach, But instead of you sort of creating the pipeline and the steps and everything from scratch, you can just use this AutoML.NET API to tell it, hey, I want to create a regression model, or I want to use something for classification. And then it's going to go ahead and take care of finding the right transforms for your data, choosing the right model for your data, and evaluating it to see which model performs the best for you. Right. So that's the AutoML.NET API. And again, that's just a layer above the Microsoft.ml set of NuGet packages. And then last but not least, you have the tooling, which is comprised of Model Builder and the ML.NET CLI. So Model Builder has it's a Visual Studio extension, so it's a UI driven approach. It has a wizard, and we're going to take a look at it a little bit later. They got you through the end-to-end workflow from selecting your data, training, using the AutoML API to find the best model for your particular data set. Now, again, because it's Visual Studio, it's Windows only, but if you are working on other platforms such as Linux or Mac, you could leverage the ML.NET CLI to do a lot of the same tasks that Model Builder would do, except now the interface is through the command line and the console, right? The other sort of scenario where the ML.NET CLI comes in really handy is in scenarios where you want to essentially go ahead and those scenarios where you want to sort of automate this. So perhaps have some sort of CI/CD type pipeline that automatically retrains and automatically deploys. The ML.NET CLI can certainly come in handy for those scenarios as well. But yeah. So with that, let me just go over to Visual Studio and show you how you would go about training a ML.NET model. So let me switch over here. Okay, so here we are in Visual Studio, and what we have here is just a blank class library project, .NET 6 class library. Now, to start Model Builder, I can just right-click here and add machine learning model. Okay, so at this point, it's just going to bring me to the add new item dialog, and you're going to see that this machine learning model ML.NET sort of item is highlighted, and you're going to see that there is it's already filled in for me. So I'll go and call it sentiment model, and you can notice also that there's this .mbconfig extension. So what that mbconfig file is going to do is it's this file it's a JSON file that preserves state. So that when you want to, maybe you want to close halfway through the training process and you want to come back and pick up where you left off, it's a really good way of sort of doing, saving that state and picking back up right where you left off. You can also use this mbconfig to sort of go back and forth between Model Builder and the ML.NET CLI. So for example, let's say you started with Model Builder, and that's kind of where you kicked off the process. But then maybe later on you wanted to automate the process through CI/CD pipelines. You can then use this mbconfig file to effectively run your retraining process inside of a CI/CD pipeline using the ML.NET CLI. So it's transferable across tooling. But yeah, so once I'm happy with sentiment model, you're going to see that it's going to create a file for me called sentimentmodel.mbconfig. And it's also going to launch the extension for me. So this is Model Builder. You're going to see here that you have a variety of scenarios here. So you have that data classification, value prediction. So that's a regression. You have image classification, recommendation, object detection. You're going to see that for a few of them, you have the option of doing everything locally. That means that you're using your own compute resources and nothing goes to the cloud. And in some, you have this option where you have Azure, where you can train your model, send your data, as well as use compute resources in Azure to train your model. And this is, again, it's something that's very useful for these more resource-intensive tasks like image classification and object detection. In this case, though, what we're going to be doing is we're going to be doing data classification. The scenario we're going to be going over is essentially trying to categorize sentiment as positive or negative. So in this case, it's asking me to select my training environment. If I had the option to train on Azure, you would see Azure here as well, and you can configure Azure, compute and all the resources that you would need from within Visual Studio. But in this case, local training is the only option using my CPU. So that's already pre-selected for me. I go ahead and move on to the next step. I then have the option of choosing a file or a SQL Server database and making a connection to a SQL Server database to bring in my data. In this case, I already have a file. So I'm going to browse using File Explorer and select this Yelp labeled setting. So these are just reviews from Yelp, and you have the sentiment text, right? And where the one, and the sentiment as well, where the 1 is positive and 0 is negative sentiment. Okay, so that's the thing that I'm trying to classify based on a phrase of text. Based on these sentences, I want to determine if my sentiment is positive or negative. Now, to tell Model Builder what my label is or what the column I want to predict is, I just go ahead and select this dropdown, and it's going to be sentiment. I also have advanced data options here, which if, for example, my data wasn't read correctly, maybe I'm using different formatting. For example, for the decimal separator, maybe I am in a locale where they use commas instead of periods for decimals. These are all things that I can change from within here. But for the time being, my data is good enough. It's not, there's nothing that I need to do to it. So I can just leave everything as is. I then go ahead to the next step, which is a training step. And in here, I select how much time I want to train for. Now, in this case, because I'm streaming, it might take a little bit longer, but this is really going to depend. And this is auto-selected for you based on the size of your data, your CPU, and different factors. So there's a lot that goes into this. So in this case, let me go ahead and set 45 seconds as my training time, and I will kick off training. So what's happening here, you're going to see there's output that is starting to come out here in the output window or the output console. And it's already found one model here. And it's telling me, hey, this is the accuracy and different metrics for this particular model. This is how long it took for me to try it. And this is sort of the iteration that it went through. And you see the same, at least for the latest model, you see that being trained here. And it's always selecting which one has the best accuracy. In this case, that's the metric that it's optimizing for. Okay, so far FastTree OVA seems to be the only one or the best one so far. Okay, now we have these LBFS, FGS. And you're going to see that. So at this point, AutoML is trying to find what that best model is for me. All right, so I just leave it and it's trying to find a model for me. Okay, it looks like it's done. You can see here that it's explored 5 different models. It took about 39 seconds to train all of the models. And the algorithm that it chose was this logistic regression OVA model with an accuracy of 79%. Now, again, going back to that question, is this good? It depends. In this case, for demo purposes, it's good enough for us, right? But if maybe this wasn't good enough for your particular scenario, you probably want to go back to the data step and try to either add more data, more representative data. You can also add more training time so that it has a chance to explore more models. There's a lot of things that you can do here to try to find a better model. But in this case, I'm pretty happy with it. You're going to see that there's some generated code behind also this consumption and this training.cs files. Now, if we were to go into those, you're going to see that the training one has this retrain pipeline, which contains all of the steps that you would need for this. In this case, it's featureized text, which basically converts the data into numbers. So machine learning algorithms typically don't know how to deal with non-numerical data. So you want to be able to transform anything that's not numbers into numbers. And that's what this featureized text is doing, because remember, our sentiment text, or the inputs that we were using to train our model, was text, and it didn't really know what that was. But when you convert that to numbers using this featureized text, you can do that. You're going to see here also that there's the algorithm that it picked, the LBFGS logistic regression. You can see that also selects the parameters for you. And again, none of this you had to do. This was AutoML doing it for you. And in terms of the code, it was AutoML. It was a Model Builder that went ahead and generated the code for you. On the consumption side of things, you can see here that we have two classes. We have the model input, which is what is the schema of what the model I'm looking at looks like. So it's that sentiment text and the sentiment sort of model, right? So this was the actual phrases, and this was at 1 and 0. And then you also have this model output, which also contains information about the sentiment text, the sentiment, different features. But what's important to us is this predicted label and the score. So the predicted label is what the actual prediction was. Is it 0 or 1? And then the score is a set of probabilities of what the model thinks was that predicted label, right? It also contains this helper method here, predict, which it uses a prediction engine, which is a convenience method for making predictions using a single instance of model input data. And then it just returns this model output to you, right? So there's all these convenience methods. So again, All this, the tooling is the one that's sort of working on your behalf and making this possible. It's auto generating this code so that you can then take it and then use it inside of your application, which is kind of what we're going to do a little bit later. All right, so I'm pretty happy here. Let me go on to the next step. So in the evaluate step, you can see again, there's that accuracy, there's the model that was used, but we can also go ahead and choose, start testing a model. So for example, here, crust is not good. If we click predict here, we can see that it is negative. So there's an 87% probability that it is negative. And yeah, it looks like it's a pretty negative comment to me. So what if I did I love ML.net? Let's see what it thinks it is. All right, so it's 94% positive that, so it's 94% probability that it thinks that it is positive, and in fact is a positive comment. So great. I mean, it seems like our model's working. So now we've trained the model. Let's go ahead and consume it. So there's many different options that you have here in terms of the consumption step. You have this this consume code that you can just copy into your application. Again, it's using that sort of helper code predict, and it's also creating this of data and making predictions that way. So you can just take this and use it inside of your application. You also have, one thing I also forgot, you're going to see that there's a zip file here, sentiment model.zip. That's our actual model. Okay. And there's, you could look into it, but there's not really anything that you find there that's particularly interesting or readable. It's just a serialized version of the model. Again, containing all of that information about what are the transforms, what's the pipeline, what is the data inputs, what are the outputs look like, and so on and so forth. Okay, so there's a few project templates that you can use here. You have a console app, which, again, as the name suggests, it's going to go ahead and scaffold a template that contains your model and everything you need inside of it as a console application. You also have this web API, which is an ASP.NET Core web API used for consuming models. And you also have notebooks. So a notebook, maybe you've seen Jupyter Notebooks. They're basically this interactive execution environment where you run code one cell at a time or one block of code at a time, and you immediately get feedback and you get that output. You can think of it like kind of like a visual REPL, right? The read, evaluate, print loop that you might see in languages like Python, maybe F#, right? It's something like that. It's just an interactive programming environment. So if I were to go ahead and add solution, in this case, I'll call us into models notebook 1, and looks good enough to me. It's going to create a file here with the IPyNB extension. And in this case, you're going to see that after a few seconds, it's going to launch this, and it contains the entire end-to-end sort of machine learning workflow. There's sort of loading your data, setting up your pipeline, choosing the algorithm, training the model, evaluating and consuming the model. And you can see here that all of those steps are outlined here, including that model input, the model output. Here's the data loading section. Here's the pipeline. So it has all of it for you. So if you wanted to go back and tinker and just go through this code first approach, you can certainly do that and see in real time what the results of making those changes would look like on your particular model and your pipeline. All right. But that's just an option. If we go back to our MB config here, I want to go ahead and actually deploy this as a web API. And the reason I want to do that is because with web APIs, you have the flexibility of basically deploying your app to the web, and your client can literally be anything. As long as it can make an HTTP request to your endpoint, you're good to go. So let me go ahead and add that to the solution and find sentiment model web API 1 sounds good. And you're going to see that it scaffolds that web API for us, as well as the MB config with the consumption code, training code, and our model here as well. And you're going to notice that this is a web API, but it only has this program.cs file. Now, the reason why there's only a file, and perhaps if you've been building web APIs for quite some time, especially with .NET Core, you might be used to things like controllers and you start a file and all those things. The template used for generating this web API application is minimal APIs, which you may have seen back during the .NET 6 release were announced, all right, a few months ago. So you start off with this builder, and that's just going to, basically configure your application. This builder has services, so you use dependency injection to add a prediction engine pool. Now, prediction engine pool is an object pool of prediction engine objects. So what this does is, because prediction engine itself is not thread safe, creating a pool of those objects that you can just share across your application allows you to better handle multiple requests at a time. Right. But at the end of the day, the APIs and how you would use this prediction engine pool work very, very much the same as your prediction engine. Now, again, it's going to take in a model input and it's going to, create a model output. In this case, also, I'm using the sentiment model.zip file. You could also use if you have your model stored in some sort of public blob storage or some sort of, place on the web. You can also load your models from a URI, right? So first from a URL, you just provide the URL, and again, as long as it's publicly accessible, you can go ahead and get your model. And the really nice thing of doing it this way as well is there's some built-in mechanisms that if you were to retrain your model and replace that file, whether that's on your local file system or on wherever else you're getting your application on the web, your application will automatically reload the latest version of the model without, with very little to no downtime, right? So it's a really cool thing there. The rest of the stuff is just sort of boilerplate. So adding Swagger and the Open API set of tooling and features, right? So this is for exploring your APIs, a little bit more Swagger stuff. And the thing that we're actually interested in is this single endpoint here. So predict. This predict endpoint takes in a prediction engine pool and a model input. And then it's just used this prediction engine pool to predict and return the results of that prediction out, right? So as you can see here, because we only have a single service, this prediction engine pool, the Swagger stuff is just really good for building these, making a more production grade application. But really all you need is this prediction engine pool and this single endpoint. So minimal APIs are really, really nice for this particular sort of application format where we just need a single endpoint that's going to take in a model input, use a prediction engine pool to make a prediction, and return that back to my client, right? So it's really, really great. Now, because this is just a standard ASP.NET Core web application, what I can do now is, actually, let me pause here. Let me go back to my slides and talk a little bit more about container apps. So we did the training, we did the consumption, or at least generate the code for it. But so now that we have this ASP.NET application, there's many different things that we can do. We can take this application and deploy it to things like Azure App Service. We can deploy this application to Azure Container Instances. Maybe we have a Kubernetes cluster with containers. We can containerize the application. So there's many different ways that we can go ahead and deploy this application because, again, at the end of the day, it's just an ASP.NET web API. But a really interesting use case or a place where we can deploy this particular endpoint to, or this web API to, is Azure Container Apps. So what exactly are Azure Container Apps? Well, they're a serverless application-centric hosting service, right, as it sort of applies here. And one of the really cool things is that you can package your code in any container and execute this code inside of this serverless hosting environment because, again, with containers, you can have basically whatever you want inside of it. And as long as whatever this hosting service can run containers, it doesn't really care about what's in there. Right? So it's very unopinionated. And it's built on the foundation of the Kubernetes ecosystem. So again, it's built on open source, it's built on open standards. And so that means that it's fairly interoperable with anything that also works within the Kubernetes ecosystem. And you can leverage that ecosystem to sort of scale and use these applications. So there's a lot of really interesting things here. And one of the really nice things that nice ways that I like to think about it is sort of serverless. And some of the really nice things that you get out of serverless, like, with products like Azure Functions, is that you don't really have to think about too much about the underlying infrastructure, right? You can just write your code, however it is that you write your code, and just deploy it to using, very, especially for these single endpoint applications, it's really easy to just focus on the logic of your code and ship it, right? The other thing with serverless is that you only pay for what you use, right? So if your application is down and you're not using it for a long period of time, you're not being charged. You're not specifically being charged for that. You're only charged for whatever you use. So that's really nice. The nice aspect of serverless. Containers but one of the drawbacks of serverless is that you're sort of bound to whatever runtime is configured for that particular service, for that version of it, and things like that. So there are some limitations there. However, with containers, as I sort of explained earlier, with containers, they're very opinionated. And as long as you have this sort of hosting environment that can run containers, it really doesn't matter what you can put inside of it. So when you put both of those together, you get that really nice overlap of Azure Container Apps. You get the best of serverless in the sense that you're not too worried about the infrastructure. And at the same time, you get some of those scaling capabilities where it can scale down to zero. But also you're not bound by the runtime, and you can really use the tools, the applications, the frameworks that you need for building and deploying your applications. So Azure Container Apps literally sits at that really nice sweet spot between both containers and serverless to help you take advantage of the best of both. So what application types are supported? Basically, this is just a few examples. You can deploy API endpoints, which is kind of what we're doing. You can have background processes, event-driven apps, and microservices. And some of the advantages, again, that I kind of went over with Azure Container Apps is that you can run containers from any registry. So whether that's Azure Container Registry, Docker Hub, wherever it is, you can essentially configure your application to run as an Azure Container App. You get the auto scaling capability, right? So based on different triggers, different events, whatever it may be, you can scale down all the way to zero. So you get that true serverless experience. But at the same time, when you need those resources, you need a lot of power, you can auto scale and get more, more capacity as you need it. You can run multiple container versions. So that's really nice. And it's specifically nice for this particular scenario of machine learning models, as I mentioned, right? You're going to want to go back and retrain your models at some point, because it's probably going to happen that the state of the world or your model no longer reflects the current state of the world. A really good example that I'd like to give about this is, let's say that you were a hotel chain, and in 2019, at the end of 2019, you were planning, okay, here's 2020, how many people we're going to get into our hotel. We're forecasting and making all these plans, and then a global pandemic hits. So whatever model you trained in 2019, the world has changed. So now that model is useless. So you need to go and retrain that model to reflect the current state of the world. And when you have multiple versions, right, now you can have multiple container versions. So you can have, you can transition from the older version to the new version, and just version your models in general, so you know which version of the model you're running. And as such, you can also split traffic. Maybe you're doing some sort of A/B test. Maybe you're trying to determine, hey, does this model perform better than this model? By splitting your traffic, you can run things like A/B tests, and sort of make also those changes to the different to the different model versions that you're running inside of your Azure Container App environment. Okay, so now that we know a little bit about that, let's go into deploying your ML.NET model as a container app. So let's go back here to Visual Studio. And again, so we have the web API. How exactly do we go about creating this, basically taking this web API and deploying it to Azure Container Apps? Well, it's relatively easy. Because it's just a .NET application, you can just right-click, add, and you can tell it Docker support. Okay. So here it's just going to ask you which target OS you want to use, and in this case, it's going to be Linux. And what it's going to do is it's going to go ahead and create a, just a standard Docker file. In this case, it's a multi-stage build, and it's pretty standard stuff. If you're not familiar with Docker, basically what this is doing is it's telling it, hey, use this sort of base image as a starting point. Open up ports 80 and 443, which are standard for HTTP and HTTPS traffic. For the build part of this, get the .NET SDK 6.0 image, and use that to do your standard things. So your .NET Restore, your .NET Build, and your .NET Publish. Just to create assets for your application that you can then go ahead and deploy. So again, these are processes that you would normally do if you were deploying without containers, right? So that's essentially what these are doing. And then last but not least, you just tell it, hey, here's how I want you to go ahead and start my application. Just run .NET and use that Sentiment Model Web API DLL to run my application, right? So it's just a series of instructions in terms of how you want, what software you need, what packages you need, how you go about building your application, and then how you go about starting your application. And that's it, right? So now you have a sort of Docker, you have Docker support for this web API. Now, at this point, you can go ahead and just right-click and say publish. So what this is going to do is it's going to take you through this wizard. And again, because this is just .NET, you can just use the existing sort of set of tools, set of applications that you're used to, to deploy this particular model. And nothing's changed. The only thing that's changed, or that might be different, is that now it has a resource, a machine learning model. But from an application standpoint, from what you would do after you've created your application, it's all relatively the same. In this case, we want to publish to Azure, and we hit next. We want to publish to a container registry, because again, we're going to sort of package and containerize this application and push it up to a container registry. If I go ahead and search for this, right, you can see that there's my resource group and there's my container registry. So I would just select that. Oops, sorry about that. It's taking a little bit of time. Yeah, so you go ahead, select that, finish. And that's just going to, again, create that publishing profile of where I want to upload my application to. Once that's sort of all set up, you're going to see there, I just hit publish. And what this is going to do is it's going to go ahead and not only build my image, not only build my Docker image, but it's also going to push it up to Azure Container Registry. Okay, so once I pushed it up to Azure Container Registry, I'm not really going to go through that process. I can then go back to the portal, or you can do this from the Azure CLI. And what you can do is you can just say, hey, I want to create a container app. So from my resource group, I tell it I want to create a container app. Sorry. Yep. So container app, and I say create. And from here, I can just select. Sorry, 1 second. Okay, so I select my resource group. I give it a name, some sort of name. I create a container app environment. The container app environment, what it's going to do is it's going to sort of create different services for logging and monitoring that are going to be shipped within my container itself. Right. So I go ahead and do that, and then go to app settings. In this case, you can use a quick start image, but in my scenario, I only want to do MLNET CA. I'm going to use Azure Container Registry. I choose my registry. Let me see. Where is it? Yeah, so there's my container registry. It's going to load the images I have. In this case, it's that Sentiment Model Web API. I can select that. I can choose the latest version, or if I have multiple versions, right, I can choose whichever version it is that I want to deploy. In this case, I get to select what I want, what the capacity is for the resources that I'm going to be using, what I want my ingress to look like. In this case, I wanted to listen for external traffic from anywhere at port 80. And I just hit review and create. All right, so at this point, if everything looks good, I can just go ahead and create it. Now, I'm not going to go through that process because it actually takes a little bit of time for it to go ahead and just deploy this. So I'm going to just go back to something that I already had deployed earlier. So you're going to see here that I have my container registry. In this case, here's my container app, my MLNET CA container app. So again, this is using that image that I pushed up, and now it's created a public endpoint for it. So I go ahead and sort of copy this link. And if I were to go and use some sort of client here, right? So let's try that sentiment again. Search crust is not good. So you're going to see here I have a JSON body sending a push request to that predict endpoint. With crust is not good. I'm going to go ahead and send that. Now, this may take a few seconds, mainly because it's been a while since I've run this application. And again, as I sort of told you, right, this is set to scale down to 0 automatically. So right now, it's probably asleep, the service. So it's going to take a few seconds because of the cold start. Okay, so give it a few seconds. And what we should see is eventually is something like, maybe you saw it earlier, is you're going to see that model output. So there's a sentiment text, just represented differently. But what we're interested in is the predicted label and the score. In this case, the predicted label is 0. So crust is not good is negative. So you see that there. That makes sense there. And then the score. So there's that probability of 0. Sorry, this is probably 1 and this is 0. So it's 81% positive, or it's 81% confident that it's a 0 predicted label there. If we were to go ahead and do something like, let's see here, crust is not good. I love ML.NET, and I hit send. You're going to see that this time it's much faster, right? So it didn't take that much time because my container is already running. So if I go down here, we can see that predicted label is 1, so positive. And again, it's 97% confident that this is, in fact, a positive comment. Bruno, I see that you have a question here. Which tool is the one you use to run the local HTTP test? So the tool that I used here is called Insomnia. It's a really great tool. It's if you're familiar with Postman, it's very similar to that. Personally, I really like Insomnia. But yeah, you can use any HTTP client you like. I know VS Code has some really great ones as well. But yeah, so it's Insomnia. Okay, so that basically brings me to, I think it brings me to the end of my talk. So I showed how you can train a machine learning model using Model Builder and the tooling there, which requires very little to no, data science ML experience. But again, you're still using the set of tools like, Visual Studio, C Sharp, F Sharp, whatever it is that you're interested in to go ahead and create these models. And then after that, you get some help from the tooling in terms of scaffolding and generating auto-generating code that's going to help bring this into help you bring this particular model into production. In this case, I showed how you can do that with a minimal API, right? What minimal web API type of application that hosts your model. You can use the built-in Docker features inside of Visual Studio to go ahead and add Docker support to your application, and then you can use those same features to right-click publish to an Azure Container Registry and use the Azure portal to go ahead and deploy this application to the web. So it's really that simple. Again, you get the benefit with Azure Container Apps of serverless, scale down to zero, and just having that sort of only pay for what you use type of scenario, right? While at the same time having the flexibility of really building your application with the apps, the services, the frameworks, and everything that you would use traditionally. So let me go back to the slides real quick, just to, so I showed how to deploy the models. Let me go ahead and make this a little bit bigger. In terms of the roadmap for ML.NET, one of the scenarios we want to add to Model Builder is time series. So you can perform, those forecasting types of scenarios. We want to make it easier to consume Onyx models. There's often, it's often a challenge. So consuming Onyx models is actually relatively easy. But what you have to do before and after to try to understand what the inputs and outputs are, kind of like that model input and model output schema, can be a challenge. So we want to make sure that we make that easier. You also want to update the AutoML. We want to update the AutoML API because the current implementation that's available in the machine learning repo is a bit different than the one that's in the tooling. So the tooling uses an implementation based on NNI and FLAML, which are two AutoML frameworks that are really good and allow you to do things like hyperparameter sweeping, as well as many other really advanced and really great features that give you a little bit more control than what's currently there. So we want to make sure that we're going to try to update the AutoML API that's currently available, so you also get the benefits of those advanced features from a code first approach. We're going to try to implement the deep learning plan, which involves basically leveraging Torch Sharp, which is a set of .NET bindings in a library that has no dependencies on Python, for building sort of PyTorch-like or Torch type of models from scratch. So you can build neural networks from scratch using that, right? And making sure that there's a higher level API that allows you to interact with those components in a more .NET-like manner, as well as, again, going back to that Onyx consumption aspect and making sure that Onyx models are easier to implement. We also want to define and implement a data preparation and a data wrangling plan. So we know that, as I mentioned, when you're wrangling data, when you're preparing your data, that's going to take a lot of your time. So making sure that you have the tools and you're able to be successful in preparing your data before you actually use, whether that's Model Builder or the APIs themselves, that you're able to be successful in preparing your data for modeling and training machine learning models. And if you like more details, you can go to this aka.ms/MLNet-roadmap link, and you can see the roadmap in more details. And again, I'd be more than happy to take questions or about anything that you saw today. And again, you can also email me and answer questions there as well.
Thank you, Louis. Before we do take off, if you have any final questions, please send them in. I'm just going to thank you and thank everyone for joining. And if anyone has any feedback, we'd love to hear about it. Please visit that link. Our event code is 15149. Until next time.
Awesome. Thanks.
Thank you.
Bye.
Bye.